Okay, good morning students. In the last class we discussed about the chemical properties of the alkaline earth metals. Okay, so now we are going to discuss about the diagonal relationship. Okay, the diagonal relationship of beryllium with magnesium. So here the diagonal relationship with of beryllium with aluminium. So as I told you, lithium has the diagonal relationship with magnesium. So this beryllium has the diagonal relationship with what? Aluminium. So here, what is the diagonal relationship? Means as I told you, because of the similar size, they show some of the same properties. Okay. So in that, so Be plus 2 ion and Al plus 3 ion so form covalent bonds. Both Be plus 2 and Al plus 3 ions forms covalent bond due to the same charge by size ratio, because the charge by size ratio of these two is same, because this is plus 2 by respective size, this is plus 3 by respective size, this charge by ratio size is same, means they prefer to form a covalent bond. Okay, so next, the covalent bond formed by these are having low melting point and they are soluble in organic solvents. Second thing. So the next one, they have almost same electronegativity value. Okay, and around the electronegativity value for them is 1.5. Okay, so they have very close value of standard oxidation states. For example, the oxidation state means the standard electrode potential required to remove 2 electron is 1.85 volt for beryllium. For aluminium plus 3 it is 1.70 volt. Okay, so this is not that much different students, this is quite are almost similar to each other, means so they form same type of compounds and they show some important properties of beryllium, and that means alkaline earth metal, that is 13th second group element, and boron family, that is 13th group element. In that beryllium and aluminium shows the same values. Okay, and these two, beryllium as well as aluminium, when they treated with HNO3 solution, it never form any nitrates because they become passive to HNO3 acid. Aluminium also become passive and this beryllium also become passive. Why? Because they form oxides, because they form oxide layer, which is a protected layer. Okay, so the next one is both react with NaOH. So beryllium reacts with NaOH, so it form what? Berylate ion, as I told you, Na2 BeO2 plus H2. Next, if aluminium reacts with NaOH, it also form Na3AlO3 plus 3H2. So students, another one thing, if both beryllium and aluminium reacts with alkali, means they form berylate ion. Like this is berylate, this is aluminate. Okay, this is also form complex, this is also form complex. So like aluminium, this one also form berylate ion, and this one is aluminate ion when they reacts with what? Alkalis. Okay, so next, when they reacts with NaOH, they form H2. Aluminium also form H2, beryllium also form H2. Okay, so when this beryllium carbide reacts with water, it form what? Methane and beryllium oxide. Similarly, aluminium carbide When it reacts with H2O, it forms CH4 and aluminium oxide. So in both the cases, they form methane, that is hydrocarbon, along with that the simple oxides. Okay, so the next one is both react with HCl slowly to form H2 gas. We know that when alkali metals are there, for example beryllium is there, if it reacts with HCl means it forms BeCl2 plus H2. Aluminium is there, it reacts with HCl means it forms AlCl3 plus H2. You may balance the equation, students, but balanced reaction, this is not theory, means they won't ask the balanced reaction. So just they'll ask what is the product formula, like that they here beryllium chloride and also aluminum chloride along with the liberation of H2 gas. And another one thing, so these forms, like for example beryllium chloride is there means that is having bridge like structure. Beryllium chloride as bridge structure. Similarly aluminum chloride also, aluminum chloride is also have bridge like structure. So they form here aluminum is there, this is Cl, this is terminal atoms. I hope you understood. So both these two form bridge structure. They form what? Bridge structure. So this is all about the diagonal relationship. First one what? Because they have similar size, charge by size ratio means they form covalent bonds. Their electronegativity is also similar, like 1.5. Their oxidation state, electrode potential for oxidation state is 1.85 and 1.70, that is so close. And both are passive to HNO3. Both liberate hydrogen when they react with alkali. When they react with alkali, again they form berylate ion as well as aluminate ion. When the carbides of beryllium and aluminum treated with water, they form hydrocarbon along with the simple oxide. When they react with HCl, they liberate hydrogen and they possess bridge structure. So this is all about the diagonal relationship of beryllium with aluminium. Okay, so the next one is, students, the biological significance of cations, that is magnesium plus 2 and calcium plus 2. So here the magnesium and calcium plays a very important role in our biological reaction, students. Okay, in our daily life we are going to use so many metals, we used to consume so many metal ions which we need for our body. So in that the magnesium and calcium, the alkaline earth metal compounds plays and elements plays a very important role. How? So this compound is responsible for photosynthesis in chlorophyll. So which one? Magnesium. Yesterday only I told you the magnesium is the metal present in the chlorophyll pigment which used for the or which is used by the plants for photosynthesis. So which contains what? Magnesium ion. So calcium occurs in animal bones and as phosphate. Calcium phosphate is there like teeth, bone. Okay, those are consists of what? Calcium plus 2 ions. Okay, so similarly, this calcium plus 2 ion is very important. It plays a very important role in what? Muscle contraction. Okay, so these acts as a energy storage in biological systems. I hope you understood. These acts as that these used to store the energy in the biological system. Okay, so these magnesium and calcium has so many importance. So another one is there, the pyrophosphate undergoes hydrolysis with the release of energy. This process is controlled by calcium plus 2 ion. I hope you in biology you understood pyrophosphate. Okay, by the production of the heat, pyro means heat, the linkage is there, hydrolysis. So in that cycle the calcium plays a very important role to control that mechanism. Okay, so in some enzymatic reactions, alkali and alkaline earth metal ions are plays a very important role. Okay, so in that, as I told, remember one thing, the magnesium plus 2, what you want to remember in the biological significance is in Mn plus Mg plus 2, magnesium is present in chlorophyll, which helps in the photosynthesis, and calcium is present in bones as a calcium phosphate. Okay, this is the biological importance. So the next one is the important compounds of alkali metals. Important compounds of alkali metals. So students, here we are going to discuss about the important compounds of sodium. So we will discuss one by one. Okay. So here first compound is sodium carbonate. Important compounds of alkali metal, that is sodium special. So in that first compound is students Na2CO3 into 10H2O. Okay, sodium carbonate, which is also called as washing soda. Na2CO3 into 10H2O. This is also called as what? Washing soda. So how this is prepared? Okay, so preparation of carbonate is manufactured by what? Salvage process. Okay, the preparation of this is called as what? The salvage process. So in this salvage process, students, first we are going to mix the NH3 with H2O and CO2. Then we will get ammonium carbonate. First, the ammonia is mixed up with what? Carbon monoxide and water, then it forms ammonium carbonate. So this ammonium carbonate again reacts with excess of water and CO2 to give ammonium bicarbonate. So this is carbonate, this is bicarbonate. Okay, once the bicarbonate is formed, NH4 HCO3, it is treated with NaCl, it forms NaHCO3 plus NH4Cl. Okay, so next students, we want what? Sodium carbonate. Okay, so NaHCO3 two times heated means it forms Na2CO3 plus H2O plus CO2. So this is what? Na2CO3. H2O is there. So it is mixed up with what? Na2CO3 into 10H2O forms what? So washing soda. Okay, so this process is called as what? Salvage process. So in the NEET they will ask what are the reagents used to prepare sodium carbonate in the salvage process, or they may ask how ammonia is converted to what in the salvage process, in the first step, in the second step, in the last step, they may ask like that, and what is the composition of sodium carbonate. Okay, the physical properties of this students, the sodium carbonate washing soda, you already known about that. So it is white in color. This is a white crystalline solid. It is a white crystalline solid which readily dissolves in what? Dissolves in water. Okay, its solubility decreases with increasing temperature. Next, if we check the chemical properties, if we check the chemical properties here. chemical properties. So in this, students, this sodium carbonate, that is Na2CO3 into 10H2O. If it reacts with CO2, it will form what? NaHCO3, that is 2 times plus H2O plus 10H2O. Okay, when the sodium carbonate reacts with carbon dioxide, it forms sodium bicarbonate. Okay, if this Na2CO3 into 10H2O, I didn't write, students, is react with SiO2, it forms Na2SiO3 plus CO2. When it reacts with silica, it forms sodium silicate. Okay. Next, when the same Na2CO3 is reacts with CaCO3 in presence of alkali, it gives what? Sorry, CaOH twice. It gives CaCO3 plus NaOH. This is 2 moles. Na2CO3 plus CaOH twice gives rise to what? CaCO3 NaOH 2 times. Okay. Next, when it is into 10H2O, when it is heated up to certain temperature, we'll get Na2CO3 into plus 10H2O. This is called as soda ash. This is called as what? Soda ash. Anhydrous sodium carbonate is called as what? Soda ash. Okay. So similarly, if this Na2CO3 is reacts with water, then it forms NaOH plus H2CO3. It forms what? Carbonic acid. Next, if this Na2CO3 reacts with acid, it forms salt plus water plus carbon dioxide. To balance this, you'll take this times, you'll get the correct answer. Next, if this Na2CO3, if it reacts with SO2, it forms Na2SO3 plus CO2. Next, if this Na2SO3 is treated with sulfur as well as H2O, it gives Na2S2O3. This is 2 moles. Okay, so this is all about what, students? The chemical properties of the washing soda. So when it reacts with carbon dioxide, it forms sodium bicarbonate, that is sodium hydrogen carbonate. When it reacts with silica, it forms sodium silicate. When it reacts with calcium hydroxide, it forms calcium carbonate. When it is heated, it loses 10 water molecules and become anhydrous. That anhydrous sodium carbonate is called as what? Soda ash. Next, Na2CO3 is reacts with what? H2O. It gives NaOH, and this reacts with HCl gives NaCl. Reacts with SO2 gives Na2SO3, and S gives this one. So this is all about the properties of that washing soda. Okay. So the next one is second one. Second one is students, that is sodium chloride. So you know sodium chloride, it is prepared by using what? Seawater. Okay, seawater is dried or ocean water, salty water especially, is evaporated in a open where in the field. Then it after the evaporation of the water we will get some amount of a residue. That residue is impure sodium chloride, because salty water, that is ocean water, may contain so many minerals, students. So that's why this one is impure sodium chloride we will get by the evaporation of the seawater. After that, what happens? That impure sodium chloride is subjected to purification. Okay, what is the how it is purified? Because the difference in the solubility is based on the impurities present in them. Because sodium chloride is easily dissolved in soluble in water, but other elements may dissolve or may not be dissolved. So based on the solubilities of those, we can do fractional distillation, okay, or fractional crystallization. So through the saturated solution of impure NaCl, HCl gas is passed. So then NaCl is precipitated first. Okay, when HCl gas is passed through the impure NaCl solution or impure NaCl element, what we get residue, then NaCl is precipitated when it is treated with what? HCl gas. The crystals are, if it is precipitated means it must be in the solid state, so the crystals are filtered, washed and dried. Okay, how the reaction takes place? So first NaCl is there means that changes to what? Na plus and Cl minus. Okay, if HCl gas in water is taken means it dissociates as H plus and Cl minus. So this Na plus this Cl minus are combined with each other to form NaCl. Okay, so next hydrogen, sorry, this NaCl is also a common salt we are going to use in our daily life, that is white color, white crystalline solid, easily soluble in water. Okay, its solubility decreases with increase in temperature. If temperature increases, the solubility decreases. Why? Because if the temperature increases, the evaporation takes place. Because of the evaporation, the volume of the liquid decreases. That's why solubility decreases. Okay, next, if we come to chemical property, okay, if we come to chemical property, so this NaCl is treated with H2O or electrolysis takes place especially, then what happens? It forms NaOH plus H2CO3 electrolysis. Okay, NaOH, sorry, plus Cl2 plus H2, because electrolysis means here in H2O, H plus OH minus ions are there, here Na plus Cl minus ions are there, so they form NaOH Cl2 and H2. Okay, this is the one type of preparation used to prepare NaOH, students. Later I will explain. So when it reacts with, when this NaCl reacts with ammonia and carbonate, it forms sodium bicarbonate with the liberation of NH4Cl salts. So this NaCl reacts with any acid, gives rise to what? Na2SO4 plus 2HCl. Here it is 2 moles. Okay, if this Na2SO4, if it is treated with carbide or carbon, it forms Na2S with the liberation of my 2CO2. When it is treated with CaCO3, again it forms what? Na2CO3. Okay, so until this we have the chemical property, but this is extra, students. If sodium sulfate reacts with carbon compound, especially carbide or a carbon graphite, it may be diamond, whatever, diamond never react, or it may be a coal. Okay, so then what happens with the liberation of CO2 gas? It form Na2S. So if Na2S is treated with CaCO3, it form Na2CO3. Next, another one is sodium hydroxide. That is third one, NaOH. So how this NaOH prepared, students? I told you by electrolysis of NaCl. So first what happen? Electrolysis means cathode reaction is there, anode reaction is there. So at cathode, this reaction takes place and forms sodium, and this anode, it releases one electron. So students, here sodium is there. So this cathode is made up of mercury. This cathode is made up of mercury. Okay, so this shell is used to, the shell where the preparation of NaOH takes place by the electrolytic method is called as Kellner cell. Kellner cell. So this NaCl solution is called as what? Brine solution. Brine solution. Okay, so this is Kastner Kellner cell. Not only Kellner cell, Kastner Kellner cell. There's, based on this only they used to ask so many questions, students. So here what happens? Electrolysis means, of course, cathodic reaction, anodic reaction takes place. At cathode this way happens, at anode this happens. So cathode means, as I told you, cathode having positive charge. Sorry, cathode means they have negative charge. Why it is called as cathode means, because positive ions attracted there. Anode means positive charge. Why it is called as anode means, because negative ions are attracted, they are deposited on this electrode. So here Na plus plus electron means gain of electron, reduction takes place. At cathode reduction, at anode oxidation. Okay, so as I told you, this cathode is made up of mercury, means it formed when Na formed at the cathode, it mixed up with mercury and formed sodium amalgam. Sodium amalgam. So when it is treated with H2O, gives NaOH. This is also 2 moles, this is also 2 moles, plus mercury plus H2. This is what? Preparation of NaOH. Okay, so then if we consider the chemical properties, so listen, physical properties means NaOH is a deliquescent pellet like crystal. Deliquescent means it is partially, or which dissolves in moisture. Okay, if we keep that NaOH solution for sometimes in the open air, it absorbs the moisture which is in the atmospheric pressure and it dissolves. That is called as deliquescent. So it is readily dissolves in water, and the dissolution of NaOH in water is a exothermic reaction. Okay, so it is very corrosive and soapy in the touch and bitter in taste. So as we come to chemical properties, students, so if this NaOH is treated with CO2, it forms Na2CO3 plus H2. Okay, this is half H2. Next, if it is treated with X2 halogens, it forms NaX plus H2O, or NaX plus NaOX plus H2O. Next, if this NaOH is treated with SO2, it forms Na2SO3, 2 moles plus H2O. Similarly, if this NaOH is treated with odd solution of X2 halogens. Okay, this one is for cold, this one is for hot. Again, it will form NaXO3 plus H2O. What is the difference, students, from here and here? Here it will form NaOX, here it will form NaO3X. Okay, so the next one, when this NaOH reacts with ammonia, it forms NH4Cl plus, when it reacts with NaOH, when it reacts with NH4Cl, it forms NaCl plus NH3 plus H2O. So these are all the properties of that NaOH solution. Okay. So the next one is sodium hydrogen carbonate. So students, here the sodium hydrogen carbonate, that is fourth compound NaHCO3. How it is prepared means the simple process is there, that is also called as what? Solvay process. The second step of Solvay process itself gives what? Sodium bicarbonate, that is NaCl is treated with NH3, CO2 as well as H2O gives what? NaHCO3 plus NH4Cl. Okay, so this is first method. And second method is there. This Na2CO3 is subjected to what? CO2 in presence of water. It forms 2NaHCO3. These are the two methods of preparation of sodium bicarbonate, called as what? Baking soda. Baking soda. So it is also a white crystalline powder and less soluble in sodium carbonate and less soluble in water too. So here, students, what happens? What are its chemical properties? Okay, this NaHCO3 upon decomposition gives what? Na2CO3 plus H2O plus CO2. Okay, so this is the only one chemical reaction. So this is all about the compounds of alkali metals. So now we will discuss the compounds of alkaline earth metals. Compounds of alkaline earth metals. Okay, so in that we are going to study only the calcium compounds. In that, first one is calcium oxide, that is CaO. How it is prepared? The preparation is CaCO3 upon decomposition gives CaO plus CO2. Okay, again CaOH twice upon decomposition gives CaO plus H2O. Okay, this temperature is up to, students, 1070 to 1270 Kelvin, 800 to 1000 degree Celsius. This is what preparation method, how this is prepared. Okay, so the next one is physical properties, that is CaO is white amorphous solid. White amorphous solid. Okay, its melting point is 2870 Kelvin. So if you want this chemical property, students, the CaO, if it reacts with H2O, means it forms CaOH twice. This preparation and the chemical properties is exactly opposite. Next, if CaO reacts with CO2 means it forms CaCO3. This one and this one is same. Okay, if CaO reacts with SiO2, it forms CaSiO3. Okay, if the CaO reacts with phosphate, it forms Ca3PO4 twice. This is 3 times. So these are all the chemical properties. Of course, this calcium carbonate, this is called as what? Quicklime, used in the manufacture of cement, used in the manufacture of sodium carbonate, used in the purification of sugars. Okay, the second one is okay. The second one is calcium hydroxide, that is slaked lime. So students, here this preparation takes place. CaO plus H2O gives rise to what? CaOH twice. Again, the CaCl2 plus H2, sorry, plus NaOH gives rise to what? CaOH twice plus 2NaCl. This is 2 moles. These two are the preparation methods for this slaked lime. So students, if this mixed with water means it forms a suspension as well as a water. The aqueous water which is present above that suspension is called as lime water, and that suspension in the CaOH twice is called as what? Milk of lime. Okay, so it is also a white amorphous powder which is sparingly soluble in water. As I told you just now, the aqueous solution is known as lime water and the suspension of slaked lime is called as milk of lime. So if you want to discuss the chemical properties of this, so this CaOH twice again upon decomposition gives quicklime and water molecule. Okay, so if this CaOH twice is treated with Cl2 at red hot condition, then it will form CaCl2 plus H2O plus CO2. Okay, so if it is, as I told you, CaOH twice, if it is reacts with Cl2 at hot condition, it forms CaCl2 plus CaClO3 plus H2O. Okay, so next one is if the CaCO3 reacts with CO2, it forms, sorry, here I'll write. If CaOH twice reacts with CO2, it forms CaCO3 plus H2O. Okay, so similarly students, if the CaOH twice reacts with SO2 means it forms CaSO3 plus H2O. Okay, so very important thing is the bleaching action. So that is CaOH twice in presence of Cl2 below 35 degrees Celsius, less than 35 degrees Celsius, it forms CaCl2 plus CaOCl twice plus 2H2O. This is very important students because this shows the bleaching action of the calcium, and this is called as what? Bleaching powder. Composition of bleaching powder: CaCl2, CaOCl2 plus 2H2O. This one specially acts as a bleaching action. When they reacts with water, it easily loses or easily gives Cl dot, chlorine radical. Okay, then it will form what? And it liberates the Cl2 gas which is white in color, results in the cleaning of the cloths. Okay, so the next one is The next one is calcium carbonate. Next one is calcium carbonate. So students, what is calcium carbonate means? How it is prepared? So CaOH twice, if it reacts with CO2, it forms CaCO3 plus H2O. This is one method. And second, the quicklime is treated with CO2, it forms CaCO3. Another one is there, the CaCl2, if it is treated with Na2CO3, soda, washing soda, it forms CaCO3 plus 2NaCl. So these are the methods of preparation of calcium carbonate, and calcium carbonate is a fluffy type powder. It is amorphous in state, a fluffy type white fluffy type powder which is highly insoluble in water. So it is insoluble in water. If we come to chemical properties, so this CaCO3 is thermally stable upon decomposition up to 1273 Kelvin. It decomposes to CaO and CO2. Again, if the CaCO3 is treated with any acids, then it forms CaCl2 plus H2O plus CO2. Okay. Next, if the CaCO3, if it is treated with another acid, sulfuric acid, it forms CaSO4 plus CO2 plus H2O. If any carbonate salts reacts with some acids, means it forms salt as well as water as well as carbon dioxide. These are the chemical properties of calcium carbonate, and this calcium carbonate is used as a what? Building material. So it is used as a flux, means the chemical used to remove the impurities in the preparation or extraction of metals in the metallurgical process. Okay, next one is very important, that is Pop, plaster of Paris. So its formula is, students, CaSO4 of H2O, hydrated salt of calcium sulfate. So here what happens, how it is prepared? 2 moles of CaSO4 into, or you will take 2H2O, that is gypsum. Okay, this gypsum is heated up to 393 Kelvin, that is called as what? Then it will loses a water molecule and form this one. CaSO4 twice H2O. This is 2 times CaSO4 into H2O plus 3H2O. Or if you divide this, students, you will get CaSO4 into half H2O. This is called as plaster of Paris. So if this CaSO4 into half H2O heated greater than 393 Kelvin, it loses this water molecule and become anhydrous calcium sulfate. This anhydrous calcium sulfate is called as dead burnt plaster. Okay, this anhydrous calcium sulfate is called as what? Dead burnt plaster. So this is a white powder you used to design the walls, or for building material it is used also, and it is used to for plastering if the bone is fractured. Okay, so the plaster mass, the plastic mass that gets into hard solid into 5 to 15 millimeter, if we had this gypsum or a plaster of Paris. Okay, so it is also a white powder. It is as a remarkable property of setting with water. So here, if it is Pop, that is CaSO4 half H2O is mixed with water, means it forms into what? CaSO4 into 2H2O, that is gypsum. So gypsum is the thing used to add, it is added to the, what is that, cement, to increase the setting of the cement, to increase the curing of the cement. Okay. So this is all about the plaster of Paris and the important compounds of the um, alkaline earth metal. So students, remember one thing, what you want to remember, some salts are there, those salts and their compositions are very important. I'll write it here. So first one salt is, that is globose salt. Composition Na2SO4 into 10H2O. Next, child saltpeter. Its composition is NaNO3. Okay. Next, nitre cake. Nitre cake. Its composition is NaHSO4, sodium bisulfate. Next, Indian salt peter. Then this is KNO3. Next, microcosmic salt. Microcosmic salt, and here it is sodium, ammonium, hydrogen, phosphate, that is tetrahydrate. Next, Epsom salt. Epsom salt is a salt of magnesium sulfate, that is hydrated. Another one is magnesite. Magnesite is magnesium carbonate. Next one is Chloride. It is also a magnesium salt. It is magnesium sulfate with 2H2O. And magnesia cement, and also Sol cement. Sols cement. That means MgCl2 along with MgO along with XH2O. Okay. Next, American baking powder. Next one is American baking powder, that is CaH2PO4 twice. So these are all the important salts or common salts that you are going to learn in this chapter. So this is all about the synopsis of S block. So in the next class we will discuss about the bits. Thank you.